There is some very classical mathematics behind fitting the regression line. So we'll have a look at it, and for simplicity we will use the one variable case. And also we'll have a look briefly at the most common measure of goodness of fit for regression models, which is the R-square. So now if we think that we have a data set and we would like to fit some straight line, so the whole idea is that we would like such a line that in overall its distance from all the data points is minimized. But that minimization is done so that we do want to penalize the most distant points. So that's why we actually use sum of squares of the distances. So we will calculate the distances between every point, which would be this xi, yi, and then the line, which is the fitted one, which is the beta 0 plus beta 1 xi. And so mathematically, we write it like this, that we calculate the differences. So for every y value, so the original y value, the observation, we take a difference with the fitted value of y, then those differences are squared and summed up for all the data points that we have in our set. And this sum of squares we want to minimize with respect to beta 0 and beta 1. So another way we can write it like this, that again we have yi, the observations, and then we represent our regression fit with a function, which is a function of the parameter vector. So theta now is basically beta 0 and beta 1, and then it also depends on the xi values, but of course these ones are given. So we would like to minimize this so-called residual sum of squares. And what it means is that we would have to find the normal equations for the straight line fit. So we take the partial derivatives of our residual sum of squares over our beta parameters, and we would like to have them equal to 0 so that we can find those values of beta that are minimizing our sum of squares. So when we plug it in and we find the derivatives, we actually end up with these two equations where everything other than beta 1 and beta 0 is given. So we can calculate those two values from our data x, y. And in regression modeling, we would like to know how good our fit is. So this is where we use the term goodness of fit.